Ever walked past a shelf full of pasta and actually wondered how it gets there? Every shape perfectly identical. Millions of pieces, all exactly the same. That's not a coincidence. Think about a box of spaghetti for a moment. Every strand is exactly the same length. Every piece of penny has the same diagonal cut on both ends. In a single box, you might have hundreds of individual pieces, and not one of them is out of place. At that scale, that kind of consistency doesn't happen on its own. Something very precise is going on between that wheat field and your dinner plate. And it's more interesting than you'd expect. Let's get into it. On Simply Understood. Pasta starts as wheat. But not just any wheat. Almost all dried pasta is made from durum wheat, a hard variety with a high protein content and a deep yellow color. Durum wheat produces semolina when milled, a coarse golden flour that absorbs water slowly, holds its shape under heat, and gives pasta that firm bite. In a factory, semolina and water are the only two ingredients in most dried pasta. No eggs, no oil, no additives. They're mixed in enormous industrial mixers, with the ratio carefully controlled. Too much water, and the dough becomes sticky and weak. Too little, and it won't come together at all. The mixing generates heat through friction, but factories deliberately keep temperatures low. High heat at this stage would start cooking the starch too early, affecting the final texture. What comes out of the mixer isn't soft and pliable like bread dough. It's dense, rough, almost like wet sand pressed together. That texture is intentional. This dough is fed into an extruder, the machine that gives pasta its shape, and the heart of the entire production line. A rotating screw pushes the dough forward under enormous pressure, sometimes exceeding 100 atmospheres, and forces it through a die at the end. The die is a metal disc with holes or slots cut into a specific pattern. Change the die, change the shape. Small round holes produce spaghetti. Larger tubes with interior pins produce rigatoni. A spiral channel produces fusilli. The die also determines something easy to overlook: surface texture. Traditional pasta, dies were made from bronze. Modern industrial dies are often made from smoother materials because they're cheaper and faster to work with. But bronze dies leave a slightly rough, porous surface on the pasta. Microscopic in scale, but enough to matter. Rough pasta holds sauce better. Smooth pasta lets it slide off. Some factories still use bronze dies specifically for this reason, even though it costs more and slows production. It's invisible to the eye, but it changes the eating experience. As pasta exits the die, rotating blades cut it to length. For spaghetti, strands hang and are cut at a precise moment. For penny, the blade cuts the extruded tube at an angle as it emerges, which is exactly how it gets those diagonal ends. The speed of the blade relative to the speed of extrusion controls both the length and the angle. What comes off the extruder is soft, moist, and fragile. It needs to be dried, and this takes far longer than most people expect. Industrial drying can take anywhere from 6 to 12 hours for short pasta and up to 24 for thicker shapes. Temperature and humidity are controlled at every stage. The pasta dries gradually, starting in warmer, more humid conditions so the outside doesn't harden before the inside has dried, then finishing in drier air. If it dries too fast, the outside contracts while the inside is still moist. This creates internal stress, microscopic fractures that make pasta brittle and prone to breaking during packaging or cooking. Properly dried pasta should be hard but not fragile. It should snap cleanly. After drying, optical sensors and cameras inspect for broken pieces, discoloration, or irregular shapes. Then it's weighed, portioned, and packaged. A large factory can produce tens of thousands of tons per year. The full process, from raw semolina to sealed box, can take less than a day. The core principle hasn't changed in centuries. Grain, water, pressure, time. What the factory has done is make it consistent. Every batch subjected to the same pressure, the same temperature, the same blade timing. The uniformity on that shelf isn't a sign that something was lost. It's the result of understanding a process well enough to repeat it perfectly, at scale, without variation, which, when you think about it, is harder than it looks.